When a fresh solution of D-glucose is prepared, its specific rotation of polarized light is 112 degree. But after 12 to 18 hours, it changes to 52.5 degree. So this change in rotation with time, it is called mutarotation. So as we already discussed, D-glucose, it has two anomers, which are the alpha and beta variety. So this alpha D-glucose, it has a specific rotation of 112 degree, and beta D-glucose, it has 19 degree. Both this alpha and beta form, they undergo mutarotation, and at equilibrium 1/3 molecules are alpha type and 2/3 are beta variety to get a specific rotation of 52.5. So the two anomers of glucose, alpha D-glucose and beta D-glucose. Glucose and fructose, they have the same molecular formula, but they differ in their functional group. Glucose has an aldehyde group and fructose, it has a keto group. So this is the open chain projection formula of D-fructose and the D-fructofuranose. So as we said, fructose ketone group is present. So this keto group, it is on the second carbon atom. So this second carbon atom is the anomeric carbon atom. It has both D and L form with regard to the fifth carbon atom. D-fructose, it is levorotatory and only D variety is seen in biological system. And fructose, it is the major constituent of honey. Next is glycosidic bond. Glycosidic bond or glycosidic linkage is a covalent type of bond which will join a carbohydrate molecule to another group. This another group, it may or may not be another carbohydrate. Amino sugars, in amino sugars, the amino group may be substituted for the hydroxyl group of sugars. So this amino group is added to the second carbon atom of hexose. So you can see here amino group is added here in glucosamine, and in galactosamine instead of hydroxyl group amino group is added. These amino sugars, they don't have any reducing property and they will not produce osazone. Examples for amino sugars are glucosamine, galactosamine and manosamine. Glucosamine, it is seen in hyaluronic acid, heparin and other blood group substance. Manosamine, it is a constituent of glycoprotein. And galactosamine, it is present in chondroitin of cartilage, bone, tendons, etc. So this amino group of the sugar, it may be further acetylated to produce N-acetylated sugar. Example, N-acetyl glucosamine and N-acetyl galactosamine. That is, at first the hydroxyl group is removed and an amino group is formed. That forms amino sugars. And then this amino group of the sugar, it is further acetylated to produce N-acetylated sugar. Then when oxygen of the hydroxyl group is removed, it forms deoxy sugars. This deoxy sugars also don't have any reducing property and they will not form osazone. L-fucose, it is present in blood group antigen and in many other glycoproteins. Then deoxyribose, as you all know, it is an important part of nucleic acid. Next we discuss about disaccharide. What are disaccharide? We have already discussed. It is made up of two monosaccharide unit, and which is the bond present. These two monosaccharide unit, they are connected together by a glycosidic bond. So disaccharide, they are compounds having two monosaccharide. So these two monosaccharide units, it may or may not be of the same type. It is classified into reducing and non-reducing. Example for reducing disaccharides are maltose, lactose, and non-reducing disaccharide, we have already said sucrose. So how do you differentiate between a monosaccharide from reducing disaccharide? We do a modified Barfoed's test. Disaccharide, they will give a negative for Barfoed's test. So here the sugar, it is made to react with Barfoed's reagent in boiling water bath for 2 minutes. So in weak acidic medium, reducing monosaccharide, they will form enediol within 2 minutes. Maltose, it is an example for reducing disaccharide. Maltose is made up of 2 glucose units. So what are the components of maltose, or which are the monosaccharides of maltose? It is made up of 2 glucose residues. And which is the linkage present? These 2 glucose residues, they are connected together by alpha 1,4 linkage. The linkage and the components are important. Maltose, it is made up of 2 glucose residue and it is connected together by alpha 1,4 linkage. It is a reducing disaccharide and it forms petal shaped crystals of maltosazone. Then isomaltose. Isomaltose, it is also a reducing sugar. The components are the same, 2 glucose unit, but the linkage is different. That is, here the linkage is between, here the linkage is alpha 1,6 linkage, whereas in maltose the linkage is alpha 1,4. So this partial hydrolysis of glycogen and starch produces isomaltose. Then the enzyme oligo-1,6 glucosidase, which is present in the intestinal juice, that can also hydrolyze isomaltose into glucose unit. Next one is lactose. Lactose is the sugar present in milk. It is also a reducing disaccharide, and in hydrolysis lactose yield glucose and galactose. So the components of lactose or the monosaccharides present in lactose are glucose and galactose. Which is the linkage present? It is beta 1,4 glycosidic linkage. It gives hedgehog or flower of touch-me-not plant like ossazone. Then comes sucrose. Sucrose is a non-reducing sugar. It is the sweetening agent and it is also known as cane sugar. This is present in sugarcane and various fruit. Sucrose, it is made up of glucose and fructose. It is a non-reducing sugar and this will not form any ossazone. The linkage, it involves first carbon of glucose and second carbon of fructose. So there is no free reducing group. It is a non-reducing disaccharide since there is no free functional group. What is the main source? Main source is sugarcane and it is dextrorotatory. But after hydrolysis, the mixture shows levorotation. So when hydrolyzed, the product will have reducing action. When sucrose is hydrolyzed, what are the components formed? Glucose and fructose. So this sucrose is non-reducing, but after hydrolysis, this glucose and fructose is formed. They are reducing. So a sugar solution which is originally non-reducing but becomes reducing after hydrolysis is identified as sucrose. Sucrose is also called as invert sugar because sucrose as such is dextrorotatory, but when hydrolyzed the sucrose becomes levorotatory. So the process of change in optical rotation from dextrorotatory to levorotatory is defined as inversion. So the hydrolyzed mixture of sucrose contains glucose and fructose, so this is known as invert sugar.